So this problem is that structure of a disease problem where basically we have a grocery store. They get 60% of their milk from dairy A, 30% from B, and 10% from C. Now it turns out that A's milk, about 3% of those go bad before the expiration date, 5% of B's, and 2% of C's. You thought 2% milk meant something else. And then if one milk is randomly selected, find the probability it is from B, knowing that it went bad. So let's just process this before we start looking at any numbers. We're trying to find the probability that it is from B, but then knowing that it went bad. So the blue is the thing we're trying to find the probability of. The red is the condition that we know must be true. Okay, so then if we follow our formula sheet as far as the conditional probability formula, then in the numerator is the intersection, or actually in this case, when we get the milk from dairy B and the milk goes bad, so that goes in the numerator. The denominator is the probability that the milk goes bad. All right, now, good idea. Whenever you have these types of problems, make a tree diagram. Weight all the branches with the information that was given to you, and then I did color coordinate a little bit. Blue is B and red is bad. Now that we have everything worked out and I've multiplied all through on all the branches, now we carefully go back here. The numerator needs to be that it came from company B and it went bad. So that's here. It came from dairy B, I guess, and that it went bad. You multiply those together, and that's the 0.015. All right, now we need to divide it by the probability that the milk goes bad. Now we rephrase using and or. Where can the milk go bad? It can go bad here, or here, or here, so we add those probabilities up. So why do we add them up? Well, we get from A and it went bad, that's that amount, or we're going to add to that, it came from B and it went bad, or it came from C and it went bad, so we multiply all those together and we add them up. So we're going to add the 0.018 plus the 0.015 plus the 0.002, and when we add all that up, we get 0.015 divided by 0.035. So that simplifies down to 3/7, which is 0.42857. So that's the probability that it came from B, knowing that it went bad. Now, we don't really have to use that formula. I mean, it's helpful, but we could shrink the sample space, which really does the same thing anyway. So if we shrink the sample space, we shrink it down to the information that was given, that the milk definitely went bad. So we can eliminate this one, where it didn't go bad, and this one, where it didn't go bad, and this one, where it didn't go bad. We're reducing the sample space down to just the 3 scenarios where the milk went bad. So out of those 3 scenarios that now have a total probability of 0.035, that's the only sample space that's left, out of that 0.035, how much of it came from B? Well, this much did. So it's 0.015 divided by 0.035 all over again. So either way, conditional probability, you can use the formula or shrink the sample space, but always take your time to plan things through, and it's a really good idea to make a tree diagram when you see a problem like that.